Hello, everyone. This is Cho from Inferences LSAT. And in this video, I wanted to share with you guys a little trick you can use when it comes to making inferences. Specifically, this is a type of inference that I found helped a lot of my students when it came to sequencing games. Now, you might have also heard this being called ordering games, linear games. They are all essentially the same thing. Sequencing games are scenarios where you are essentially being asked to determine the order of where certain entities or game pieces get placed. And this is a very common type of situation where you have six entities in total. You know that each entity shows up exactly one time, just based on the parameters of the game, which I will probably be creating a video about how to determine those parameters. So stay tuned for that. But you've probably seen like situations like this where you have rules that are kind of determining the order or the relative placement of various different entities. And I find that a lot of times people maybe intuitively grasp a few inferences based on this, but a lot of times they fail to come up with all of them. And as you can see in just a minute, you'll find that going through the effort of finding all of them oftentimes actually yields even more deductions down the road. And hopefully at this point, you do recognize how important inferences are. If you go into questions without having a thorough understanding of the inferences, a lot of times you end up having to try out all of the answer choices, which ends up taking forever, right? Especially if you end up drawing out a new game board for every single answer choice. So this is designed to help you be able to kind of push through that process and not have to try out every single answer choice and go through this brute force method for every single question that you encounter. Okay, so let's kind of see how this works. So if you look at the rules, the first thing is you want to kind of consider where can these entities not go. Start with the negatives, because a lot of times once you determine where an entity cannot go, that can actually help you determine more accurately where the entities can go. And that can oftentimes be very, very useful, as you will see in just a minute. But let's first kind of go through a very specific process you can utilize for determining this, which, by the way, I call this the apparent inference process. These are just inferences that are apparent just from single rules alone without having to combine multiple statements together. So let's start with entity F. With every single entity, you want to find all of the apparent inferences before moving on to the next. A lot of times, people will jump around. They might find something for F. They might find out, for example, F cannot go into 6, which is true. But then they'll jump over to L, then they'll come back to F, then they'll go to G, they'll go to H, then they'll come back to F, and so on. If you are doing that, it's going to take way, way longer. And on top of that, you're not going to be 100% confident about your inferences. You will always be kind of feeling like maybe you missed something. You're not going to be 100% sure. So to avoid that, you want to ask yourself two questions. For one, how many entities must go before, okay? And then two, how many entities must go after? Notice how I'm using the word must, not could, okay? So you always want to ask yourself those two things. And if you can accurately ask yourself those two questions, then you would have found every single deduction. Okay, so let's start off with F. So how many entities must go before F? We have to be careful here. Remember, in this case, this is just saying F goes before H, G goes before H. It's not actually telling me anything about F and G's specific relationship. So that ultimately means actually no one needs to go before F. And so in that point, that means there's nothing I can cross off for the game board. The second question I'm going to ask myself then is how many entities must go after F? Again, G could go after F, but it doesn't have to. G could just as easily go before, so I'm not going to count that. However, I do know that both H and L need to go after F. Now, that's two entities, right? Now, however many entities you count will be the number of slots that you cross off. So as soon as I see that F cannot go, or I'm sorry, as soon as I see that F has two entities after it, I'm going to count from the right side of the game because H and L are going to the right of F, right? So I need to have enough space to accommodate for those entities. And I'm just going to simply count these two spaces, okay? One space, two spaces. Okay, so F cannot go in either of these, right? So notice how I'm not testing out F going into 4. I'm not testing out F going into 5. I'm just using numbers just to immediately tell where I can cross them off from. Next up, I can do the exact same thing for G. How many must go before G? None. F could, but that doesn't count. How many must go after G? Just like with F, it's actually 2. H and L, those are the 2 entities that must go after G. I'm going to count from the right side of the game board because H and L are going to the right of G, 2 spaces, and that means G cannot go in either 5 or 6. Moving on, now we can try out H, okay? And so if I take a look at H, I'm going to count how many entities must go before it. Remember, we said F goes before H, G also goes before H, right? So that's going to be 2 entities going before. So I'm going to count 2 spaces, but this time I'm counting 2 spaces to the left of the board, right? Because F and G are going to the left of H. So that means H cannot go in either 1 or 2. Okay, so then from there, I'm going to count how many entities must go after H or to the right of H. The answer is 1. It's L. Okay, so I'm going to cross off H for 1 slot from the right side of the game board. Last but not least, final part of the chain. For L, how many entities must go before L or to the left of L? 3, right? We have F, G, and H all going before it. So I need to count from the left side of the game board 3 slots, and L cannot go in any of these 3 slots. Okay, so now, and then finally, I'm going to count how many must go after L. The answer is 0. And notice how we can confidently go through all of the apparent inferences for this entire chain just by asking ourselves 2 questions about each individual entity. Okay, so at times it might feel a little bit iffy at first. You might not be 100% confident with it, but that's where you want to be repeating it, reviewing these questions time and time again so that it becomes much more fluid and much more methodical. Now, we also have to remember this same thing can be done for K and J because after all, we do have a constant order between K and J here, right? K has to go before J. So if I take a look at K, how many entities must go to the left of it? 0, nothing I can do there. How many must go to the right of it? 1. Okay, so which is J, of course. So then I'm going to count from the right side of the game board, 1 space. K cannot go into 6. Last but not least, how many must go to the left of J? Also 1. So I'm counting from the left side of the game board. 1 space, J cannot go there. And also another thing to notice here is I have a separate row for each of these entities. I'm not like merging these together. Notice how I didn't place like H up here along with F, even though I easily could have. So the reason for that is because notice how by having these distinct rows, it's very easy for me to tell which entities are restricted, which ones are not, right? So for example, it's very easy for me to see, oh, you know what? L is crossed off from 3 spaces. L is actually pretty limited. It's not super limited, but it's kind of limited in terms of where it could possibly go. Whereas like other entities, like maybe J, for example, seems like it has a lot of wiggle room, right? So, but this can only be done when I have a separate row for each of these entities like I have here. Imagine if I kind of mushed everything together in the same row, it would be very, very messy. The game board would be very cluttered, and it would be difficult for me to find those particular inferences. But going back to the point earlier, if you recall earlier, I was saying that sometimes these apparent inferences, although each of them individually might not seem like a huge deal, they can oftentimes add up to some pretty valuable deductions. So for example, if you notice over here, slot 6 is actually very restricted. We've crossed off 4 entities. We only have 6 entities in total. So that means we only have 2 entities that could possibly go into that slot. That is a meaningful inference. That is something that could potentially help us when it comes to the questions. In fact, a lot of times questions ask about that. So I'm going to go back to my entities and I'm going to say, well, who's left, right? So we've taken care of F, G, H, K. That leaves only J and L. Those are my only 2 options. So I'm going to go ahead and add that to my game board. I'm just going to go ahead and put J/L, and then I'm good to go. Now, keep in mind, of course, you can have other types of deductions as well, but this should give you a really good foundation, and this should be a process that you should be implementing in almost every sequencing game, right? There are a few exceptions here and there, but generally speaking, this is a good approach to use, and you'll find that it can help you develop confidence much more as well.